Good day, guys. This is your tutor engineer. Today we are continuing with our series on motion in one dimension. We'll be doing graphs on today's lesson. So let's start. Jack rides his motorbike on a straight line, on a straight level road in a direction due east. The following graph shows his velocity as a function of time. So this is the velocity time graph for Jack's motion. So let's read the first question. Describe the motion of the motorbike from point C to point E in words. So we focus on point C all the way to point E. So looking at the velocity time graph, we can say between C and D, velocity decreases from 10 meters per second to 0 meters per second. And then between D and E, velocity increases, right? So this portion says velocity is increasing from 0 meters per second to to this point here, which is another 10 meters per second, so to 10 meters per second. So we can qualify with the direction west since the velocity is negative, and then it's going to be east when the velocity is positive, owing to the original direction that the motorbike was traveling on. Okay, so that would be the description. Let's go to 12.2. Calculate the motorbike's total displacement at each moment B, C, D, and E. So we'll calculate the displacement at B, at C, at D, and then at E. Okay, let me just share something with you. If you are given the velocity time graph, to get the displacement, that means you need to work out the area to get to the displacement. The area under the velocity time graph will give you the displacement. So if they ask us to calculate the acceleration, that means here you need to work out the slope for acceleration. So the slope of the velocity time graph is the acceleration. Now, okay, let's deal with the displacement as the question requires of us. So that means we'll calculate the area. So let's write next to the graph for simplicity. So the area between point A and B is this triangle here. So we'll say the displacement between A and B is equal to half base times height. Since that one is a triangle, our base is 10 seconds, and then our height is 10 meters per second. So this will give us 10 times 10 times half, which is 50. Since displacement is a vector quantity, you're going to say 50 meters east. And then at point C, we'll do likewise. Displacement between B and C, that now will be the area under the rectangle. So the area of a rectangle is base times height. Our base between 10 and 30 is 20, right? This distance here is 20. So our base is 20 times the height is the same as the 10 meters per second. So here will give us 200 meters east. And then between C and D, displacement between C and D is going to be the area under this triangle. The base between 30 and 32, that will be 5 seconds, right? So half base times height, half the base is 5 seconds, then the height is 10 meters per second. That would be 50 divided by 2, it will give us 25 meters east. Now let's do the displacement at between D and E, which is going to be this triangle, that small triangle there. So also the base is 5, between 35 and 40, that is a 5. So we'll have half base times height. The base is 5 seconds. The height is minus 10 meters per second. So since we are dealing with the displacement, we are not forgetting the sign of minus 10. So that will give us minus 25 meters. Since it's positive, it's negative, the answer we'll say is 25 meters west, right? Remember, this sign is telling us that the bike is now moving in a displacement towards the opposite direction, which is west. Okay, so let's now we've answered question 12.2. Okay, let's do 12.3. 12.3 calculates the total distance covered by the motorbike during the 40 seconds. So it's the total distance for the entire duration of 40 seconds. Okay, so distances are related to displacement in some way. The difference is when you're dealing with a total distance, you don't take a direction into account since it's a scalar quantity. So now the total distance for the entire trip will be 50 plus 200 plus 25 plus 25. So we're not taking the minus sign into account, we're just going to make everything positive. So let's write here 50 plus 200 plus 25 plus 25. That will be the total displacement. Sorry, it's the total distance. So what will it give us? 50 plus 200 plus 25 plus 25 is 300 meters. No direction required. So now let's go to 12.4. Draw the displacement time graph to distinguish between the 4 sections of the graph. Okay, we've already worked out the displacement at various points. Remember, 10 seconds is point C, 0 is A, and then 20 seconds. Do we have 20 seconds? Let's check. We don't have. Okay, point C is at 30 seconds, and then D at 35, and then E at 40. Let's write that one down. So D is here, E is here, so this is 35, and then okay, something is missing there. So it's A, B, C, right? So I made a mistake here. Let's just correct that mistake. So this is B, C, D, E. Now let's choose the total displacement here. Let's just make a total so that you can budget it on our graph scale. So when you add everything up here, the total displacement is going to give us 50 plus 200 plus 25, right, minus 25. Remember the sign, minus 25, that's a total displacement. So 25 and 25 will cancel each other, so we'll have 250 meters. So let's just, to account for that 250 meters, let's count everything in 50. So this will be 100, 150, 200, 250. Probably going to continue a little to 300. Okay, so let's choose a different color for the graph. At point B, our displacement was 50, right? 50 east, right? So we're going to write here between 10 and 50 when I make a point here. And then at point C, the displacement is accumulative, that's the difference. So now at point C, we're going to accumulate. Let's just write here so that we keep track. At point B, we said it's 50, right? And then we mark the point. At point C, we added another 200, so that will be 250, right, at point C. So point C here, 250 is there. So the straight line will continue, and then at point D, that 250, the very same 250, you're going to add 25 on it. So we'll have 275. So that is point D. So 275 is about here. So let's make a point there, 275. And then at point E, that 275, you're going to subtract, since the displacement between DE was negative, subtract 25, we are back to 250. So we'll mark 250 there. So the graph will look like, since the velocity was increasing between A and B, is going to be a curve. So that's going to be the first impression. Here is going to be a curve. So it's actually not a straight line, it's a curve. Let's just make it a little bit prettier than this. It's going to be a curve, something like that. It's not really a straight line. Since the velocity between 10 and 30 was constant, straight horizontal line, so this one will be a straight line. Oh, wait a minute, this is not the correct point. Let's wrap off this line. We're going there, right? In fact, let's start from there. So this one will be a straight line, and then since the velocity between C and D was decreasing, it's going to be a curve. The velocity, where the velocity is 0, so that means our displacement would be at its peak. Then it's going to be a curve going down. So this is actually a curve, like a parabola graph. So this is going to be our displacement time graph. I hope you understood. If you like, you can write the values. Here you have 50, 250, 275, and another 250. Okay, let's continue on with 12.5.1. Define the acceleration. So the acceleration is a vector quantity. We'll say it's a vector quantity, which is a rate of change of velocity it's measured in meters per square second. And then number 2 says calculate the acceleration of the motorbike during the last 10 seconds. Remember what we said. We said to find the acceleration, you need to work out the slope of the velocity time graph. So now, okay, let's write question 2 here for simplicity. We still have a little bit of space. We'll make our calculation here. So this is 12.5.2 for acceleration. So on the last 10 seconds, this is the last 10 seconds, right? So this is the last 10 seconds between C and D. So our acceleration will be the slope, right? So at point C, we have the coordinates at C. The time is 30 seconds, and then the velocity is 10. And also the coordinate at E, the time there is 40 seconds, and then the velocity is minus 10. So we can work out the slope. So we'll say minus 10, or we can just write the equation of the slope is going to be y at point E minus y at point C divided by x at point E minus x at point C. Y at E is minus 10, then y at C is 10. That's divided by x at C, x at E, I'm sorry, it's 40, minus x at C is 30. So this will give us at the numerator minus 20 divided by 40 minus 30 is 10. The answer is minus 2 meter per square second. Or you can write, since the acceleration is a vector quantity, 2 meters per square second west in the opposite motion. That's the acceleration. Okay, so we've worked out the acceleration west. What does the sign of the velocity tell you about the motion of the object? So whenever the velocity is positive, right, which means that the object is moving in the original direction, which in our case is east direction. So when you get the negative velocity, which means the velocity is moving in the west direction. Okay, so the next question says, what does the sign of the acceleration tell you about the motion of the object? So if you get to the positive acceleration, it means the velocity, right, velocity is increasing. It is increasing towards the original direction, which is in our case is east. When the acceleration is negative, it means the velocity is also increasing, but only in the opposite direction, which is west. Remember, in physics, you never get a number less than or smaller than 0. Our acceleration was, you remember that we got a -2. In physics, -2 is greater than 0. Unlike mathematics. I know in mathematics, you are taught a number line of saying -2, -1, 0, 1 and 2, and they tell you that you're increasing in that direction. In physics, 0 is the lowest number you can ever get. So when you get an acceleration which is -2, it means the velocity was still increasing, but in the opposite direction towards the west. When the acceleration is positive, it means it was still increasing, but towards the original direction, which is east. I hope you understood that part. So we've come to the end of our today's lesson. If you liked today's lesson, please subscribe and stay tuned on the next lesson. Cheers.